Hey, this is Pat Martin, and in this installment of the Dex videos, I'm going to go through some new charts and visualizations that are based off of ECharts. So I'm going to start off with a Cartesian chart, and I call it that because it has an XY axis and it covers things like scatter plots and line charts and stuff like that. So in the documentation, it goes through the basic flow. We get the doc, we read the CSV, we look at the data, and then we visualize it. And over here in glaring red is a comment that there is some bugs in the JavaFX WebView browser. It's based on a really old version, I think a 2012 or earlier version of the WebKit, and it's not fully HTML5 compliant, and some of the eChart stuff rides the edge on some of that compatibility. So we're going to see a few problems, but we can easily work around it by saving our asset off to an HTML page and then opening a fully compliant browser like Chrome. So I'm going to go ahead and execute this. And the first thing we see is what I was saying. So the lines are shifted to the right of the scatter plots over here. So I'm going to save this off, and I'm going to call it test. And I'm going to go into the browser, and then I'm going to reload this directory, and there's our new test file. And when we look at it in Chrome, everything's hunky-dory here. So I'm going to go ahead and interact with the chart a little bit and show some of the things I really like about eCharts. And over here, we can hover over, we can see that this is OC and the garbage collection data, which is the old capacity. So with the eCharts, the legend is fully interactive, and it's one thing I really love. We can turn things off, we can turn them back on, so we can, and the chart just refreshes, smooth as glass, and it's really nice. So, and we can do the same thing in this view, but the misalignment is kind of a problem. So I'm going to go here, I'm going to configure this, and let's see. We'll go under miscellaneous, and I'm going to start off maybe by changing the symbols to be larger. We see that updates real time or near real time. We can change the symbols to arrows, to diamonds, to rectangles, rounded rectangles, whatever you want. So there's quite a few shapes that are inside of eCharts, and we fully expose those. So next thing I want to do, well, before I do that, I'm going to go ahead and stack the series. So we're going to see these lines shift on top of one another. I'm going to unstack it. It goes back to like it was, and I'm going to go to the scatter plot. So in this case, we don't have those misaligned lines because there are no lines. So we can again change the symbol size. We can switch this over to the effect scatter, which is just like the scatter, only it has sort of a kind of like a halo effect. And I'm gonna go ahead and save this off and show that our changes are being persisted off. And I think when we look at this in Chrome, it's gonna look a little smoother than it does in the web view. But or maybe not. So it's kind of hazy. Okay, what happened to my window here? There we go. Okay, last but not least, I'm going to show the bar chart, and in this case it doesn't render, and this is even a bigger WebKit bug, but again, save it off here, and I'm hoping that the later version, Java 9, that they're going to update to a later version of the WebKit, and I have my fingers crossed to see if some of these issues will go away. My only other alternative would be to look at something like Ceph and look to integrate my own Chrome-based browser. So anyway, that's the Cartesian chart. Now, good news is that that's probably the most problematic of our charts so far. And in this flow, again, we have documentation. We're going to read in some president data, old tried and true data set I work with a lot. Take a look at the data, select the columns. We're going to look at party, home state, and president, and then we're going to visualize it as an ECharts network. And there you go. So again, one of the real nice things is that interactive legend. So it allows us to sift through the data and really focus on the connections that we care about. Now, next thing I'm going to do is I'm going to go into the configuration for this, and I'm going to go under miscellaneous, and I'm going to just switch the layout to a circular layout. So again, it lays out, it observes the selections we made previously and renders it in a circular layout, which is a really nice way to be able to visualize this data as well. In some cases, it's a lot cleaner. So next thing I'm going to do is I'm going to go through, I'm going to go through the different ways we can categorize the data. So when we categorize the data, it's going to connect the data differently, and it's going to give us different legends over here. So I'm going to select column type, and in that case, since we have 3 columns, party, home state, and president, we're going to see the nodes that are, in this case, Democrat versus Republican. We're going to see everything colored by the column type. So it really makes it easy to see the relationships across columns when we do that. And I'm going to go to column value, which may not make sense for this because we have way too many column values. But in this case, other data sets that may not be the case. But here, every column gets, every distinct column value is going to get a distinct color. It's going to get a distinct node, and it's going to get a distinct representation in the legend. So if you have the real estate, or if the data set makes sense for something like that, this one doesn't, then that's another way you can categorize stuff. So each column is also going to get a selection here. So home state becomes, home state value means that for every distinct value within the home state column, it's going to be colored, get its own color and its own node. So here we see Virginia, Massachusetts. So basically all the states get their own distinct colors and nodal connections in that particular model. Let's see. You can go in none, which in that case is just going to color everything the same and everything's uncategorized. We could color by party, which I think we did before. We can color by president, but again, there's too many presidents really for that to make sense. But and we can also again change the symbols if we choose to. We'll go back to coloring by party value, and I'm gonna turn these selections back on, and I'm gonna shift back into the force layout. But actually, before I do that, let me just go ahead and save it off. Replace that test file and reload this page, and we can see it rendered pretty true to our representation over there. And we have that same interactivity. And what's nice is this is a self-contained asset. If you look at this, it's just a file being loaded by the browser. So it doesn't require a web server, though it would happily operate on a web server. And this is nice because it has no external dependencies. So let's say you use jQuery, jQuery UI, or whatever the latest and greatest JavaScript libraries are out there. Since we're using a point-in-time snapshot, these things aren't going to break. So they're going to be pretty resilient. The only thing that could really break them would be changes to the I'm not sure how to say that word, ECMA specification. So JavaScript, the language changes, and that could break it maybe. So okay, where was I? Okay, I was going to move back to the force layout. And this is kind of clumped up and cluttered together, and I'm going to turn the Republican back on. So other things we could do here is we could mess around with the gravity. So we could increase the gravity, so that's going to compress everything. Or we could maybe decrease the gravity to 0, and then things are going to spin off. I'm going to add a little tiny bit of gravity. Add that back, and and I'm going to increase the repulsion between the nodes because I'm really trying to get some separation, but I want it to fit in the page too. So I'm going to increase the edge length and maybe decrease the repulsion. Maybe that's too much. Change that to 100. Okay, so that's one thing that you got to be careful about is when things spin out of control, and you kind of got to bring it back in by manipulating gravity. I'm going to add a bunch of gravity. I'm not sure if I'm helping or hurting. Kind of reminds me of in Star Trek where they pivot around the sun to increase speed. I think that's some of that same reaction that's going on here. So I'm going to decrease the repulsion. Okay, that did it. Alright, so different ways that we can play around with this stuff, and you know, like as you just saw, you got to be a little bit careful with how you change those things. I should probably put some safeguards in, but right now we're kind of operating without a safety net here, so I'm going to go ahead and save that off and reload it over here, and looks like it saved at a point where the nodes were really far away from each other, so I'm not really sure what happened there, but I'm going to move on. So I guess it's officially a demo. We're seeing plenty of bugs here, but I'm going to move on to the next view, which is the single axis scatter plot. So again, we're going to read a data set called births and deaths. We're going to select out 3 columns: country, year, and deaths per 1,000 people, and then we're going to render it onto a single axis scatter plot. So I really like this view, and again, ECharts offers really nice facilities here, like this ability to quickly select and slide and pick those pieces of the chart that you're interested in, slide it across. And I'm going to save this one off to the test.html. Let's see what's happening with this thing. Nothing. And it stays pretty true to form here. And one thing I like is, you know, Chrome is a lot more performant than the web view too. I love the hooks into the web view from Java. That's invaluable to me. But the performance is always going to be better in something like Chrome, just because they have the V8 engine and a lot of things that the web view just doesn't have, being based on an older WebKit. So the way this lays out, and over here we see gaps because there are no data points there, and the points are laid out for whatever years they do have data, side by side by side. Everything's lined up, and you can do a direct comparison across the vertical axes. Now, other things we can do with this, since this is kind of busy, so we could go over here, we could do our own selective customization here. You know, maybe we can change it to diamonds or whatever shape we want to see. We can play around with the scale if we wanted to see things at a different size. We could switch over to the effect scatter. Not sure that's going to add any value to that, or in this case we'll switch back. And then we also have the ability to play around with the different style aspects to each one of these items. So maybe we want to change the opacity to something where we can easily see the legend, the labels behind it. Let's see. Then we can also play around with the labels. Now, you know, maybe we want to show all the labels, maybe we don't. Looks like that's doing something other than what I expected. I think that's going to be it for this particular visual, and I'll go ahead and save it off and replace that, yes, and refresh that, and looks like it just applied our size, the size changes I made afterwards, but it didn't reflect over here. So that is a minor bug, which I'll fix. Okay. Next is the timeline. So love this view. Some people call it a motion chart. ECharts calls it a timeline. So in this flow, what we're going to do is we have documentation, which we're reading over here. Read the CSV, view the data, select the columns, and this chart looks for it's very specific. So that's the reason I select the columns in order of the data types. And what it's looking for is a numeric. So the first numeric is going to be used on the x-axis, then the second column is going to be used for the y-axis, then size, then a categorical category, and then a sequence, typically something like time, like year or something like that. But it doesn't have to be. As long as it's something that can be, as long as it's numeric data, that should be fine. So I'm going to go ahead and I'm going to execute this. And there we go. So what we're seeing here is on the y-axis the percentage of deaths, or the number of deaths per 1,000 people, and the burst across a number of countries. We can hover over it, and this is the US, this is Brazil, this is Mexico, and there's a couple of controls here. And over here we can pause, we can play it just like a video, or we can move it to whatever year we want to see, and we can quickly cycle through the changes in the data. So it's a really nice way to look at many different dimensions at the same time, and be able to take a look at the trends over time, kind of like the Gapminder visualizations. And it's really easy to put this stuff together too, and it's pretty flexible. It works quite well. Alright, so next one is going to be the polar plots. I guess, well, okay, I could have styled this. I probably should have, but I forgot. So I'm gonna just go ahead and move on. Basically, every one of the charts can be styled and customized. So this one also has that line problem, but what we're doing here is, in a little groovy script, I'm creating 3 columns: the series, the angle, the value. And the first series is sine, second series is cosine, and as I iterate through all the degree angles, I convert it over to radians here, take the sine and cosine of it, and put the angle in the data too. So data set looks like this, plot looks like that, and again we can do cool things like turn off the sine, then we just see the cosine, turn them all off, turn them all back on. So I think that's all I'm going to do. I'm going to skip customization of this one. I'm going to move on to one of them that I'm more familiar with to customize. So I've got the polar plot on a garbage collection analysis, and I'll go ahead and save this one off to the test file and look at it inside the browser. And again, you see those lines that didn't render quite right. So what I have is I have the series axes being the number of garbage collects up to that point, and then along this axis over here, what am I actually choosing here? Okay, it's using the old utilization and in the Eden utilization. I'm going to choose a more intuitive example to do the customization. So I'm going to move over to the third polar plot view, which is the census view, and what we have here is we're reading in some data based on some census data, year, age, marital status, sex, one for I think female, two for male. It doesn't really matter because we're not really using that portion of the data. Next thing we do is we create in place, in memory, a table, and we call it census, and we use strict type. So if it encounters a numeric type, it's going to store it in a decimal field, and that's important because we're doing things like summation and stuff like that on here. So then we query the data, and this is really just a fancy select, and what it's really trying to do is it's trying to give us the percentage of population across particular age groups for that particular year. So last but not least, I'm going to jump over here into the view, and the default is going to I believe use year for the series index, and then it's going to use age for the radius index, and population for the value over here. So that's the reason the scale looks, I guess it's going to use population and age across the angle index, which is, as you go across here, that's the angle axes, and up and down here is going to be the radius axes. So I'm going to save this off. We're going to produce some more diverse views out of this data in just a second. So I'm going to go ahead and reload that. Now this is what you don't see because of that line bug. The bug with the lines is it's a pretty interesting view because we can quickly turn off particular years, some of the noise, and let's say we want to do a direct comparison between the year 2000. I wish I had a button to turn them all off. It'd be easier, but I don't. So here we can do a direct comparison between the year 2000 and the year 1850. So population-wise, wow, what a difference. A huge difference. It may be somewhere in the middle, like 1930. And it's a really nice way to be able to do a direct comparison across these polar coordinates. So I'm going to go into the configuration, and I'm going to start off here, and I'm going to say, okay, well, I'm going to just change this to a bar chart. Save that off as is. Reload it over here, and then we get that same view in a bar chart. Now I'm going to start to change this a little bit more drastically. Let's see. Looks like I've got two configuration options over here. Oh, that's my old network one. Okay, gotta be careful about closing those things. Make sure you have the right one, that you're configuring the right thing. So now that I have the bar chart, I'm going to go here into the series and axes, and I'm going to just play around with this a little bit. So I'm going to go ahead and stack the series. So they'll be stacked one on top of each other. Doesn't render exactly right there, but when I jump over here, we're going to see this viewed entirely different. So we'll see everything stacked one on each other. We can easily turn series off through a bunch of clicking. And I'm going to, let's see what I do there. Okay, so I'm going to change things around a little bit. So on the angle axis type, I want to make that dynamic, so it'll just adjust to whatever the value is. And I want to make the radius axis category data type, I want to make that a category. So I'm sort of forcing, even though it may be numeric data, I want to treat it as a categorical piece of data. And my value index is going to be the percent of the population, and my radius index is going to be, I want to change that to, well, I'll keep that. I'll make that age. And my angle index is going to be set to none, and my series index will be set to the year. So it looks blank here, but when I save this off, And when I reload it over here, we're going to see a chart that's stacked in a radial fashion. So we can go through and select those years that we want to see, and we can pretty much look at the entire distribution of the population for, this is 1850, so 14.6% was in a range of from 0 to 5 years old, from 5 to 10, 13.8, and then when you get over here into the 60s, 1% of the people made it to 65 to 70, versus year 2000, which let me turn some of these off so it's easier to see, versus the year 2000, which highlights over here, 65, we got 3.2% versus 1%. So people are living longer, not a big shocker there. Okay, so another view I'd like to put together real quick is, let's keep the percent population, and let's change the radius index to be year, and let's change the series index to be age. So now we can turn off the age demographics and turn it on and off via the legend. I'm going to save it to the HTML page over here. Reload this sucker. And now, since we laid it out this way, every year has the percent of the population, if you remember correct, that it's basically all the way to 100 for each one. It ends up being 100% for each one. So basically, what we can do is we can do a direct comparison across the years to see. I'm going to turn these other age groups off one by one. Turn these off, and say if we want to take a look at the percentage of the population that was from that was 0 to 5, then we could easily compare it. And more people were, a larger percentage back were younger earlier on, because I guess they died off and they had more babies and stuff like that. So there's some other settings I can do to make these axes, that make these labels not run on each other. I could play around with the label rotation, stuff like that, but just trust me, the options are there. I'd rather cover some of the other chart types that we can do here in time we have. Okay, so let's see, last but not least here, go to scatter. Actually, I'm not sure. I'm gonna go ahead and rerun it just to reset all the settings here, because I'm not really sure what's going to happen. Okay. So let me configure this to be a scatter plot. Okay. So again, we got the age on the angle axes, and we got the population across this radius axes over here. And we can do things like we could change the title, we could add some text, hello there, and that's going to update real time. Subtext, I am subtext. Pretty cool stuff we could do. We can actually add links inside the visualization if we wanted it to link to external content. We can do some alignment. We could change the text style, and let me scroll here. Change the text color, say to pop a little bit more. Maybe I'll change it to some little bit of red here. Maybe I'll make the font a little bigger, maybe a little too big, but I'm going to keep it for now. And this one should say subtext style, but I can do the same things for the subtext. So I can make the subtext a little bit brighter, a little bit more pronounced there. Change the color over to, I don't know, maybe blue. And move on to scaling. So over here, if we would like to see a little more separation between these nodes. I could change the minimum radius, and that'll update real time. I could change the different scaling methods to use a log. That kind of moves them closer together, it looks like in that case. Use a power scaler, and that one I'm not sure if I implemented that one yet. Looks like maybe not. So I'm going to hopefully change that back to linear. Okay, and I think that's basically all I wanted to cover. So that's it, and hope you enjoyed this video. And if you are interested, reach out to me on Twitter or via email. Let me know suggestions, etc. Thanks a lot. Bye.